Imagine this for a moment. Look at your plate. The rice, the bread, the vegetables, the meat. Now pause and imagine half of it vanishing. Not because of war, not because of drought, but because the world simply cannot grow enough food. Fields stretch to the horizon, yet the soil is empty. Farmers work harder but harvest less. Cities grow larger while hunger grows faster. No farms producing enough food, no fertilizer to restore the land, no way to feed billions of people. This isn't science fiction. This was the future many experts feared just over a century ago. Here's a shocking truth that most people never hear. Nearly half of every human alive today would not exist without one single invention. Let that sink in. Not electricity, not modern medicine, not computers, not the internet, but a quiet chemical reaction hidden inside factories, pipelines, and steel chambers invented more than 100 years ago. An invention so powerful that every second of every day it helps turn air into food. An invention that silently supports farms on every continent, that fills grain silos, that keeps supermarket shelves stocked, that feeds over 2 billion people every single day. Most people have never heard its name. Most have no idea their lives depend on it. Yet without it, modern civilization as we know it would collapse. This is not just a story about chemistry, it is a story about survival. This is the story of the invention that saved the world from mass starvation. This is the story of the science that fed the world.
At the start of the 1900s, the world was in serious trouble. Human numbers were rising faster than at any other time in history. Medical advances reduced death rates. Industrial cities expanded rapidly. More mouths needed food every single day. But agriculture was falling behind. Fields were being farmed again and again, season after season, and the soil was exhausted. Harvests grew weaker. Crop yields stopped increasing. Farmers faced one invisible but deadly enemy: nitrogen. Plants need nitrogen to build leaves, stems, seeds, protein. Without nitrogen, plants turn yellow, stop growing, and die. No nitrogen meant no food. Here was the cruel irony. Nitrogen makes up 78% of Earth's atmosphere, surrounding every farm, every field, every crop. Yet plants cannot use nitrogen gas from the air. Nitrogen in the atmosphere is locked in a tight chemical bond, making it unusable to plants. Crops can only absorb nitrogen when it is fixed into forms like ammonia or nitrates. Before modern chemistry, humans had only a few natural sources of fixed nitrogen. Farmers depended on animal manure, collected slowly and in small amounts. Compost, which took time to decompose. Bird droppings, called guano, mined from remote islands. Guano became so valuable that nations fought over it. Entire economies depended on seabird waste. But these sources had limits. Manure could not match population growth. Compost could not restore exhausted soils fast enough. Guano deposits were being emptied and shipped across oceans. By the late 1800s, experts began to panic. Countries were literally running out of fertilizer. Scientists and economists warned of an approaching disaster, a future later described as the population bomb. More people than food, rising hunger, mass starvation on a global scale. Some predicted that civilization itself would collapse under the weight of its own growth. It seemed unavoidable. Nature had placed a hard ceiling on how much food humans could grow. And then, in the middle of this growing fear, One scientist dared to ask a question so bold it sounded impossible. What if we could take nitrogen directly from the air, break its unbreakable bond, and turn it into food? That single question would soon change the fate of humanity forever.
That man was Fritz Haber. Haber was not just intelligent, he was obsessed with solving impossible problems. At the beginning of the 20th century, many scientists believed that fixing nitrogen from the air could not be done. Nature did it slowly through bacteria and lightning, but humans? That seemed unrealistic. Haber refused to accept that limit. In his small, cramped laboratory filled with pipes, glass tubes, and steel chambers, he focused on one bold idea: force nitrogen and hydrogen to react no matter how difficult it is. This was a nightmare challenge. Nitrogen molecules are extremely stable. They're like two atoms locked together with an unbreakable chain. They simply do not want to react with anything. Hydrogen, on the other hand, is reactive, but useless without nitrogen giving in. To break nitrogen's resistance, Haber pushed chemistry to its limits. He experimented with extreme heat, raising temperatures so high that metal equipment glowed red hot. Still, nitrogen refused. He applied crushing pressure, compressing gases thousands of times stronger than normal air pressure. The glass tubes shattered, valves burst, experiments failed again and again. Then Haber tried metal catalysts, substances that could encourage the reaction without being used up. He tested iron, osmium, uranium, and rare metals. Most did nothing. Some worked briefly, then failed. Months turned into years. Many scientists would have quit. But Haber noticed something important. When nitrogen and hydrogen were exposed to high pressure, high temperature, and just the right metal surface, tiny amounts of ammonia appeared, then disappeared. That was the clue. In 1909, after countless failures, Haber finally achieved a breakthrough. Inside a reinforced steel reactor, under higher temperatures over 400 degrees Celsius, pressures over 200 times normal air pressure, and using a finely tuned metal catalyst, boom! Nitrogen and hydrogen combined to form ammonia consistently. For the first time in human history, nitrogen was pulled from the air and turned into a usable chemical by human design. It wasn't efficient, it wasn't safe, it wasn't ready for the world, but it worked. And in that moment, inside a small laboratory, humanity crossed a line. We no longer had to wait for nature to feed us. We could manufacture food itself. That single reaction would soon reshape agriculture, population growth, and the future of civilization itself. For the first time in human history, ammonia was made directly from air. Haber had done the impossible. But there was a problem. His method worked in a lab, not in the real world. To feed billions, it had to be scaled up. That's where another genius entered the story. Meet Carl Bosch. If Fritz Haber proved the idea could work, Carl Bosch had to make it survive reality. Bosch was not just a chemist, he was an engineer facing one of the most dangerous industrial challenges ever attempted. He worked for a German chemical company called BASF, and his task sounded simple on paper. Turn Haber's laboratory experiment into a machine that could feed the world. In reality, it was an engineering nightmare. To make ammonia in useful amounts, Bosch had to push materials far beyond anything used before. First, pressure. The reaction only worked under pressures so extreme that steel cracked like glass, pipes split open, entire chambers exploded without warning. At the time, no industrial machine on Earth was designed to survive such force. Next, heat.
The reaction demanded temperatures hotter than lava from a volcano. Metal weakened, bolts warped, welds melted. Factories literally tried to tear themselves apart from the inside. Then came the most dangerous problem of all: hydrogen. Hydrogen leaks through metal. It makes steel brittle. It turns strong walls into fragile shells. Entire reactors failed silently until they exploded. Bosch realized something terrifying. The industrial materials of the modern world were not good enough. So he did something radical. He didn't just redesign the machine, he reinvented industrial materials themselves. Bosch and his team developed new steel alloys that could resist heat and pressure, designed multi-layered reactor walls to stop hydrogen damage, built safety systems no one had ever attempted before. Years passed, factories blew up, workers were injured, money was lost, experts mocked the project. Many said, "This process is too violent for industry. It will never be safe. It cannot be done." Bosch ignored them all. After relentless testing, redesigns, and sheer stubbornness, the first industrial ammonia factory finally succeeded. It ran day and night. It didn't explode. It didn't fail. For the first time, ammonia flowed not in drops, but in tons. This industrial system became known as the Haber-Bosch process, and once it started running at full scale, everything changed. Fertilizer could now be produced endlessly. Food production was no longer limited by nature. Human population growth accelerated like never before. Air had been turned into bread, and the modern world had just been born.
If you're enjoying this deep dive into the hidden science that shaped our world, hit the like button. It helps this story reach more people. And subscribe for more powerful true stories like this one. Now, let's see how this invention changed humanity forever. The Haber-Bosch process allowed humans to make unlimited fertilizer, grow crops faster and bigger, turn air into food. For the first time in history, farming was no longer limited by nature. Wheat yields doubled, rice production exploded, cornfields spread across continents. Today, 50% of the nitrogen in your body comes from this process. Nearly half of the world's population depends on it. Experts estimate over 2 billion people are alive today because of this invention. Without it, mass famine would have swept the world. Entire civilizations could have collapsed. Modern cities may never have existed. It wasn't just an invention, it was the foundation of modern civilization. But this story has a shadow. Every powerful invention carries two paths, one of creation and one of destruction. The discovery that could feed the world could also arm it. The same ammonia used to make fertilizer can be transformed into explosives like TNT and ammonium nitrate bombs, military propellants used in artillery and ammunition, chemical precursors for weapons of war. The chemistry is the same, only the intention changes. And tragically, Fritz Haber himself walked down that darker path. When World War I erupted, Haber believed it was his patriotic duty to help his country win. He turned his scientific brilliance away from farms and toward the battlefield. Haber became a key figure in the development of chemical warfare. Under his direction, poisonous gases were designed and deployed, filling trenches with invisible death. Thousands of soldiers suffocated, blinded, or died in agony. The irony was devastating. The same mind that helped humanity escape mass starvation also helped introduce some of the most horrifying weapons ever used. Haber's personal life reflected this tragedy.
His wife, a chemist herself, strongly opposed his work on chemical weapons. Unable to accept what science had become in his hands, she took her own life. History would forever remember Fritz Haber as a man of contradictions, a savior of billions, and a contributor to immense human suffering. His invention fed the world, but it also fueled war. This forces us to confront a difficult truth. Science itself is neutral. It does not choose compassion or cruelty. It does not decide how it will be used. That choice belongs to humans. The same knowledge that can grow food can also destroy lives. And the future of science, like the past, depends entirely on the values of those who wield it. Every time you eat, remember this. Your food does not only come from farms, it comes from air, steel, and science. One invention, one chemical reaction, 2 billion lives saved. If this story changed the way you see the world, share it, subscribe, and comment. What invention do you think changed humanity the most? Because the next story might be even bigger than this one.